Hello, I'm Dr. Dennis Bielfeldt of the Christ School of Theology here at ILT. We're talking about Aristotle's logic. I was going to do the whole lecture on Aristotle's logic last time, but I decided to break it because it got a little long. So we were back, if you recall, we were back at A-E-I-O. All S's are P, no S's are P, some S's are P, some S's are not P. And what Aristotle did is he distinguished various figures, he called them, of argumentation, which he called modes, actually, or moods, moods. So various figures. And then he gives us rules of deduction by which we can arrive at conclusions in these various figures. So hold in your mind the A-E-I-O. Everything presupposes the square of opposition. But we're going to talk about the figures of Aristotle with regard to argument forms. Now, in logic these days, of course, we derive all kinds of things from one premise or many premises, right? But for Aristotle, I mean, he's really thinking of this situation where we have two premises, right? And he's really thinking that a conclusion follows from two premises. Now, let's say that all S's are P. I can imagine a guy saying that, right? By the way, all S's are P. Oh, let me tell you something. All P's are Q. Well, what can one possibly conclude from such a thing? Well, looks like we could probably conclude that all S's are P, right? No, we can't conclude that because, of course, we already said that. All S's are Q. We could conclude all S's are P, but it really doesn't advance us anymore because it's just a restatement of the premise. All S's are P, all P's are Q, and all S's are Q. Now, the thing to realize that in every argument form, valid argument form, you have a middle term. One term has to be used twice, and here it is. And if you have a situation where your middle term lays out in this way, with the diagonal running down and to the left, this is called figure 1. All S's are P, all P's are Q, all S's are Q. Now, the major premise is the antecedent of your conclusion. You look at the antecedent of your conclusion. There's S. Ooh, it's up here. It's appearing up here, so that's the major premise. And then the Q is at the consequent there in your conclusion. All S's are Q. So then you look up there and you say, well, that's appearing over here, so that's your minor premise. That's how you get your major and minor premises, okay? So figure 1 runs this way. So we will now compare that with other figures. So figure 1, we'll just put it this way. All A's are B, all B's are C, all A's are C. There's figure 1. Figure 2 goes like this. Let's say all A's are B, all A's are C, and then all B's are C, right? Well, of course, that wouldn't follow. But if we change the character of the propositions from a universal affirmative to something else, we're going to find that many things follow this way. Now your middle term is there, right? On the left side. That means it's figure 2. And there's your major, minor. That's still your major premise. But there's your middle term, okay? Now, we have a third possibility, and I bet you can almost figure out what this one might be. Someone might say some A's are C, right? Somebody else might say, well, every B is a C, so what can we conclude from that? Well, something about A's and B's, maybe, I don't know. Now, there's your terms over there. Your middles are on that side, so that's figure 3. So figure 3 Figure 2, Figure 1. Everybody understand this? Okay, good. Figure 1, Figure 2, and Figure 3. Now, of course, I'm saying all A's are B, but of course, that's just A propositions. What Aristotle has is 4 kinds of statements, A, E's, I's, and O's. And from certain statements of A and E, in certain figures, certain other things follow. You can derive validly conclusions. Now, back to our A, E, I, O. We have a rule that Plato points out. It's called conversion. And a conversion is when you take the terms and you commute them. Right? So, for instance, I could say all A's are B. It wouldn't follow that all B's are A, would it? But the conversion of all A's are B is all B's are A. Get it? Conversion wouldn't follow for A propositions, but it does follow for E propositions, right? Because no S's are P. It follows from no S's are P that no P are S's. And it follows for I as well. Some S's are P. It follows that some P's are S's. But it wouldn't follow for O. Again, it doesn't follow for O. So conversion works for E and I propositions. We say that E and I convert. And Aristotle also said that all A's are B, converts to some B's are A, because of course he then believes in existential import. So you can move from there to there for Aristotle. But for you, just think your conversion runs that way. And then contraposition is when you convert the terms and negate both of them. So classically in logic, that's a conditional, P then Q. Conditional converts as follows. That's actually valid, not Q then not P. Okay. So which of these convert? All A's are B. Well, not convert. Which of these contrapose? All A's are B actually contraposes to all not B's are not A. But E and I do not contrapose, but E contraposes. Remember, we have E, or not E, O. Some S's are P, contraposes to some non-P, right? We got to negate. Now, but then we have to negate the entire thing. Some non-P, what? I'm sorry, this has got to be not here. So we got to convert this to some not P. Some A's are not P. Some non-P are not non S. Okay? So you have a contrapositioning that way. Now, we've got 2 rules then. Conversion, contrapositioning. I'm going to show you another rule. This is called aversion. And in an aversion, you negate the entire proposition, and then you also negate you change the proposition if you go from A to E, and then you actually negate the second term. So, all S's are P's. Okay. all S's are P's, goes to no S's. See, A goes over to E. No S's are non-P, right? No S's are non-P. All S's are P, so no S's are non-P. And this works for everyone, but we'll just go down and do it for O. Some S's are not P. Now goes to, now you go from O to I. Some S's. Now you got to negate your P, are non-P. You're going to say, whoa. So I get to use a version, and I go from some S are not P to some S are non-P. Well, yes, that's what you have to do. You have to use a version here, and you can derive this. Now, although Aristotle doesn't draw this out with Euler or Venn diagrams, it is kind of easy to see these things if we think about them set as sets, of course. All S's are P is just that, right? No S's are P is just this, right? You have disjunct sets. So you can certainly see why that would convert, right? And then, of course, we have some S's are P. Well, right? Some S's are P. And then now we're down at O. Some S's are not P. There's your S and P. Some S's are not P. Well, that would be some S's are not P, right? So if you ever get lost in these rules, you can always go back and check it that way, and they all make sense. Okay, so now what do we get from all of this? Well, we can get some valid deductions. And the way that the Aristotle did it, well, he proved these things. The way that the tradition learned it is to think of valid deductions in terms of some nice Latin words. See? So the schoolboy would learn which figures are valid by memorizing some Latin words. Okay? So one, Barbara. Yes, no, Barbara is not a new term. Barbara wasn't invented by Americans a few generations ago. The word's been around. Barbara. Okay, now there's 3 A's, right? So you think A. Okay, so that means all S are P, all P are Q, therefore all S's are Q. Barbara holds in figure 1. What else holds in figure 1? Well, let's see. The second term after Barbara is celerant. Celerant. Of course, I got to spell it right. Celerant. Right? And here we have E-A-E. Okay, so in figure 1, that would be some. Oh, E is. Oh, that's. No S's are P, A, right? All P are Q. Then we follow with another E, right? Proposition. No S's are Q. No S's are P, all P are Q, thus no S's are Q. That seems to follow. Then we go to, I'm not going to do this, Dari. And there we got an AA or an AII, so that's all S's are P, I, some P are Q, therefore cancels out, some S's are Q. Dari. Then we have ferio. So the next word here for eyes are ferio. So we have these in figure 1. Okay. Now you can memorize all this stuff. I just assume not. I'd rather just do logic. This stuff is interesting historically, but it's not really at the cutting edge here. But it is kind of fun to work out proofs with syllogistic logic using rules, and you can prove these various things. Figure 2, we've got some other words. We've got cassara. Remember figure 2, the A's come down this way, or your middles come down this way. Figure 3, the middles come down that way. Commistrace, right? It says Fatino. I think it's Festino. It doesn't really matter. We just got to get an E, I, and O out of there. And Boracco. You can see how that would work with Boracco. And then figure 3, if you want to look down in your slide there, you can see it at the bottom of the page. It should be over there. Darapti, Philopton, Disamis, Datisi, Baccardo, and Therison. Right? So these are our valid deductions. If you were a schoolboy, you could learn those, memorize them, and then you could do logic. Of course, what happens here is you end up doing logic. It's a lot of the way that students learn mathematics. They can't really prove anything. They just want to, get a formula so they can work the problem set. And that really doesn't make you a great mathematician. In my estimation, mathematics is all about inference. So it's all about it's all about, if you've ever read mathematics books, it's all about that stuff that isn't the problem set. When I was a kid, I always thought the problem set was important, and then I got older, I realized the problem set really wasn't that important. What's important was how you derive the formulas. Okay, now from this comes a lot of metalogical conclusions. Now, when I talk about metalogical, you're saying, what does that mean? It means beyond logic, but you have to see that logic makes use of an object language. The object language is the A-E-I-O. All S's are P, no S's are P, some S's are P, some S's are not P. But we can talk about the object language with a language beyond the object language. We can say that an A proposition follows in figure 1 from 2 other A propositions. So if you have A, then A follows. Now that's you're using a meta language to talk about your object language. I could say something like this. I could say that in figure 1, then I might say A and A give A. All right, that's A is a semantic consequence of A and A in figure 1. Now I'm talking about the object language with my meta language. Okay, logicians are always interested in metalogical results. What are the properties of the logical system, and what kind of derivations are possible in that system? What are valid in that system? So Aristotle gives us some elementary metalogical conclusions. No deduction has 2 negative premises. Now what he means here is no valid deduction. From 2 E's you can't go anywhere, right? From two O's, you can't go anywhere. From an E and O, you can't go anywhere. You don't have a valid argument if you have an E and an O. From two particular premises, you can't go anywhere. You don't have a valid argument from an I and an O, or an I and an I, or an O and an O. If you're going to have an affirmative conclusion, then both of your premises must be affirmatives, right? He proves this stuff. It's pretty amazing, right? A negative conclusion must have a negative premise. If you're going to have a negative conclusion, that is either an E or an O coming out, you better have an E or an O going in, right? A universal conclusion needs two universal premises. So if you have an E coming out, you better have an E and an O, an E and an E, or an E and an A going in, or an A and an A, and the same with a E coming out. Did I say? No, what I meant is if you have a universal conclusion needs two universal premises. If you have an E or an A coming out, I'm sorry, then you have to have E's and A's going in. So this is a lot about logic. Of course, for us, we talk about logic being truth functional, and this is not something that Aristotle would have talked about in this way. But we could make some comments about this, but we won't at this particular point in time because this is an introductory lecture on Aristotle's logic. And we'll be back soon talking about some more themes of Aristotle's work. Thank you.